Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Actually I am reviewing the electrochemistry and I have discussed many points. All fundamentals I have discussed. Now what are the remaining? Today I will finish. Now I will discuss liquid junction potential. What is liquid junction potential? Liquid junction potential you can understand like that when two electrolytic solutions are directly in contact, ions move across the junction with different speeds. As a result, a potential difference is set up at the junction. It is called liquid junction potential. That is the LJP, liquid junction potential. The EMF of the cell is thus the sum of oxidation potential of one electrode, reduction potential of the second electrode, and the liquid junction potential. That is the sum of these three type of potential. Potential at potential due to the oxidation at one electrode, and reduction potential of the second electrode, plus liquid junction potential. If you will add all these three, then it will be the total potential. Total potential. Then here you have the important thing is that when two electrolytic solutions are in direct contact, suppose you are taken two solution A and B, and if both will mix to each other, both will come, you can tell if they are in direct contact, both solution, then what will happen? That ions of both solution move across the junction, near the junction, with different speeds. Ions will be of different speed. This is the important thing, sir. Then due to the different speeds, they will reach, because speeds are different, then all will not reach at a time. Then ions move across the junction with different speeds. As a result, because two types of charged ions are having different charge, are coming close, then they will create potential. Correct? Then when two electrolytic solutions are directly in contact, ions move across the junction with different speeds. As a result, a potential difference is set up at the junction. This is called liquid junction potential, LJP. Then what will be the total EMF? Now actually EMF is generally due to the anode and cathode, oxidation potential at anode and reduction potential at cathode. Sum of these two is called EMF. But due to this liquid junction potential, now what you were thinking, now it will be more. Okay, because liquid junction potential will add in that. Then actually this EMF will be the potential at anode, and that is oxidation potential plus reduction potential, that is actually E cell. But here due to the extra liquid junction potential, its EMF will increase. Means theoretically you were calculating others value, and experimentally you will get other value. That is due to the liquid junction potential. The EM of the cell is thus the sum of oxidation potential of one electrode, reduction potential of the second electrode, and the liquid junction potential. That is, if E is the EMF, then E is equal to E1 plus E2 plus Eej. Eej means potential due to liquid junction. Okay. Then this sum of these three is actually EMF. EMF is equal to E1. E1 means first electrode, anode, plus E2, second electrode reduction potential, plus liquid junction potential. All three if you will add, then actually you will get the EMF of the cell. The types of junction generally applied in the galvanic cell. You remember, the type of junction generally applied in the galvanic cell. That is the salt bridge. You might have heard already many times I discussed. The type of junction generally applied in the galvanic cell is the salt bridge, which contains salts like KCl, in which K plus and chloride ions have almost equal speeds. Hence, Eej is taken as 0. It will be cancelled because it will not create a potential, because both will move almost at equal speeds. Both will reach together. Then they will cancel. There will be 0 potential. If difference is there in a speed, only then potential will be created at the junction. This is the important thing. That's why in salt bridge, that type of salt is used whose ions have almost equal speed. Okay. Then KCl is the best example. Potassium sulfate is also there. Then now I discuss about the liquid junction potential. Now absolute ionic mobilities. How will you calculate calculation of absolute ionic mobilities? This is a very important term. Calculation of absolute ionic mobilities. Mobilities means always related to movement of ions. Okay, just in this you keep in mind. Mobility means here ions movement. In just in a brief, just in a general way, you consider these things. What is actually, how will calculate calculation of absolute ionic mobilities? The absolute ionic mobility is defined as the speed of the ion in centimeter per second at infinite dilution. Means too much, you can say, dilute. Solution must be fully diluted. That is called infinite dilution. Because that time ions will be free to move, no restriction. Freely ions will move. That is the meaning of infinite dilution. But under a potential gradient of 1 volt per centimeter, how will these ions will move? Then when you will apply potential gradient, means how much potential? Per centimeter. You consider gradient means per centimeter, volt per centimeter, means each centimeter how much volt is there. That is important. That is actually called potential gradient. Then here if we will apply 1 volt per centimeter, then that time means at infinite dilution under a potential gradient of 1 volt per centimeter, that is called actually potential gradient. Potential gradient here is equal to applied EMF divided by distance between the electrodes. Okay, very easily you can calculate. Applied potential divided by distance between the electrode means per centimeter how much volt is there, easily you can calculate because you are dividing by distance between the electrodes. Suppose you are dividing by 10 centimeter, then per centimeter you are calculating. Then you remember always potential gradient is equal to applied EMF divided by distance between the electrodes. This concept will be useful in solving the numericals. Hence, its units are, what is the units of absolute ionic mobilities? Then its units are centimeter per second divided by volt per centimeter. Correct? Units, how will you calculate? Then units are centimeter per second. You remember, centimeter per second divided by volt per centimeter. Correct? Volt per centimeter. Two things you have to consider. That is the speed. Speed is, what is the unit for speed? Centimeter per second. Then speed divided by potential gradient. That is actually absolute ionic mobilities. Speed divided by potential gradient, not only potential gradient means volt per centimeter. Then now you just write the unit of both speed and potential gradient. Then speed is centimeter per second divided by potential gradient, that is the volt per centimeter. Then now after solving, after simplifying, you will get what you will get, that centimeter square, because upside centimeter is there, down per centimeter is there. Then if you will take it upside, it will become centimeter square. And upside per second is there, leave it per second. And voltage down, it will go up, then it will be per volt. Hence unit of absolute ionic mobility is centimeter square per centimeter per volt. You remember. Question is asked, unit of ionic mobilities, absolute ionic mobilities, and that is equal to centimeter square per second per volt. It is related to ionic conductance. You remember, relation is also important. This ionic mobility is related to ionic conductance. How? Then I am telling you now. Ionic mobilities is equal to ionic conductance divided by Faraday, means 1 Faraday, that is 96,500 coulomb, means per coulomb, how much conductivity is there, ionic conductance per coulomb. Correct? Then per coulomb ionic conductance, that is called ionic mobility. This is the second important relation. Ionic mobility is equal to ionic conductance divided by 96,500 coulomb, that is 1 Faraday. This relation is very, very important. Remember, this will help you in solving the numericals. Now, next term I am discussing, that is the reversible and irreversible cells. Reversible and irreversible cells. Just to try to understand, a cell is reversible. A cell is reversible if the cell reaction can be reversed by applying opposite voltage greater than that of the cell. Here just voltage you have to make change. A cell is reversible. Name itself is a reversible. A cell is reversible if the cell reaction can be reversed. Reaction, if means A to B, suppose it was going on. Forward reaction was A to B. Now by applying the, you can say, potential, if now reaction, suppose reaction takes place now B to A, then reaction is reversed. Then that time it will be called reverse reaction. Then a cell is reversible if the cell reaction can be reversed. How we will reverse? Then by applying opposite voltage greater than that of the cell, because you are changing the direction. Then obviously what was the voltage there, now you have to apply more than that. Suppose voltage was 2 volt, then now you have to apply more than, when 2 volt was there, then it was going from A to B, reaction was going in this direction, A to B. If you will apply more than 2, 2.5, 2.2, 2.3, more than 2, then now direction will change. This you remember. Okay. Then a cell is reversible if the cell reaction can be reversed by applying opposite voltage greater than that of the cell. That is, in the Daniell cell. On the other hand, example is the Daniell cell. Okay. That is a reversible example of reversible cell is Daniell cell. On the other hand, a cell is irreversible if the cell reaction cannot be reversed. That is the, in I can say Zn in H2A. Suppose Zn is dipped in H2SO4. Copper is also dipped in H2SO4. Both are in H2SO4. Zn in H2SO4. Copper is also dipped in H2SO4. Then that this cell is, you can write Zn oblique H2SO4 oblique Cu. You can write like that. Means between the Zn and copper, H2SO4 is there. This is the example of irreversible cell. You remember, zinc is one electrode, copper is another electrode. Between the two, H2SO4 is there, sulfuric acid. Then this is also a cell, but this is a irreversible cell. Then a cell is irreversible if the cell reaction cannot be reversed. Example is, that is the Zn in H2SO4, copper in H2SO4. Or you can write between the two electrode, H2SO4 is there. You can separate it. You can write like that, Zn oblique H2SO4 oblique copper. Means between the zinc electrode and copper electrode, H2SO4 is there. Now next term and last term of this chapter I am going to discuss. That is the addition storage cell. Addition storage cell, also called nickel iron accumulator. Nickel iron accumulator. It has two names, addition storage cell or nickel iron accumulator. You should know how you will represent this cell. Representation is very, very important. Then here what you have to do, that iron rod, iron is solid I am talking about rod, F is solid and APO, both you have to take. Iron plus ferrous oxide, APO, both you have to take. Correct? Means here you can understand that APO will convert, AP will convert to APO. Simple way. AP solid will convert to APO. Correct? Means oxidation reaction. Fe is converting to APO. Means what? APO means oxygen is too negative. then Ap will be positive, means oxidation. Then this is the anode. I told you always that at anode oxidation takes place and at cathode reduction takes place. Then anode is here, Fe is converting to FeO. Then Fe bar FeO you can write. Both are solid. Fe solid oblique FeO solid. A small, you can bracket, you can write a small s. S means solid. This is the anode. Now cathode is Na2O3, nickel oxide. Now nickel oxide is converting to nickel. Nickel oxide Na2O3. Then Na2O3 means Na2O3. 3 means just opposite way you have to think, cross. Then nickel is nickel oxidation state is +3 and oxygen is -2. That is the meaning of Na2O3. This 3 is telling about nickel and Na2, that 2 is telling about oxygen valency. The nickel valency or oxidation state you can tell it is a +3. Then Na2O3 is converting to nickel. The nickel is metal. Now 0 oxidation state, any metal, 0 oxidation state. Then now you can see +3 now converted to 0, means it has taken the electron reduction. Gain of electron is reduction. The nickel 3 plus, it has taken electron from the anode side. That anode lost the electron. Nickel got the electron. Hence Ni3 plus now converted to nickel metal. Then this is the cathode. And between the anode and cathode here, that you will separate it. You know that this will be there. Salt bridge will be there. That you are indicating by 2 parallel line. And what will be the electrolyte? In cell you have to mention the electrolyte also. Then here electrolyte you will use KOH, aqueous KOH. Aqueous means water, means potassium hydroxide must be dissolved in water. Then electrolyte is used here KOH. Then you can represent addition storage cell or nickel iron accumulator like FeS/FeO. S means solid, both are solid. This is the anode. And cathode is Na2O3 oblique nickel. And one salt bridge you have to write 2 parallel line. And KOH, after that you should write between the two electrodes. KOH, potassium hydroxide, will be used as aqueous solution. Potassium hydroxide, that is the electrolyte. And what is the half cell reaction? Then already I have discussed, again I am telling you, at anode, that is the Fe. Actually Fe will lose the electron, loss of electron at anode. But how? Simply it will not lose. Then in presence of OH ion, KOH you have taken electrolyte. Due to that, actually in presence of OH ion, ferrous will lose the 2 electron. Fe plus 2 OH minus, means here OH means KOH. Then now Fe will convert to FeO. O is coming from OH. Then FeO plus if you will balance it, then FeO plus H2O plus 2 electron, because Fe has lost 2 electron. And now this 2 electron will be taken by, who will take? Then this will be taken by nickel. Then at cathode what reaction will take place? Then Ni2O3 solid. It is actually solid. Ni2O3 is solid. Then Ni2O3 plus H2O reaction will take place in aqueous. that due to that there H2O will be there. Then Na2O3 plus H2O plus 2 electron from anode side. Then now here product you will get what? Na2O3 will convert to actually NiO. NiO reduction taken place. NiO means what? Ni is plus 2 because oxygen is minus 2. Then Ni is plus 2. Then here you can see Ni2O3. Ni was plus 3 state. Ni was plus 3 state. Now it became 2 plus 2. Plus 2 means it got 1 electron. That's why plus 2 became plus 3 became plus 2 because it got 1 electron. Then this is actually reduction. And after that it will give 2OH. Then in final reaction 2OH will be cancelled and 2 electron will be also cancelled. Means half shell means anode reaction. Half shell is oxidation reaction at anode and other half shell reaction is reaction at cathode. Then now you add both. Then 2 electron will be cancelled out. OH will be also cancelled out because in both reaction you will get OH, but one will be left side, other will be right side. Hence both will be cancelled. Hence finally what you will get? Then finally you will get Fe plus NiO2 left side and right side FeO plus 2 NiO. Correct? Means ferrous oxidized. Fe became Fe plus that you are writing as a FeO. And Ni2O3 which was in plus 3 state, now it became plus 2 state. NiO. That's why now it is a plus 2 means reduction taken place. Then now overall reaction is Fe plus NiO2O3, that is converting to FeO plus 2NiO. Now chapter is finished and next class I will start other things. Okay, other chapter or other chapter I will start. Okay, thank you.